So let's do a couple of more examples on solving some linear equations. These examples will involve decimals and fractions, and we're going to work them in a very similar way. Instead of working with the decimals and fractions, we're going to actually use the multiplication property of equality, and we're going to actually multiply by a number that will eliminate the decimal or the fraction. So for example, in this first one here, we have 6/10, 1 3/10, and 2/10. So in order to eliminate the decimal, I will simply need to multiply both sides by the number 10. So 10 times 6/10 is 6. 10 times 1 3/10 is 13. 10 times 2/10 is 2. And I haven't distributed, so I'm going to keep my parentheses around that 5x minus 8. Now it's just an equation like every other equation, and I am going to distribute the 2. That gives me 6x minus 13 equals 10x minus 16. Then I'm going to start moving my terms. I'm going to move the 6x to the right, because I like my x's to stay positive. You don't have to, but that's what I choose to do. And then if I'm going to move my variables to the right, I'm going to move my constant to the left. So that's going to be plus 16 plus 16. What that gives me is a 3 on the left, and it gives me 4x on the right. And since I need a coefficient of 1 in front of the x, I'm going to divide by 4. So that gives me x equals 3/4. Or, since we started out with decimals, let's end with decimals, 0.75. Okay? So we're going to do something very similar with the fractions. I'm going to look at what's called the least common denominator, or least common multiple. I'm looking at 3, 6, and 2. So the least common denominator, the least common multiple of those numbers is 6, because 3 times 2 is 6, 6 times 1 is 6, and 2 times 3 is 6. So that's my least common denominator, or least common multiple. I'm going to multiply both sides by the number 6. What happens is it's going to actually eliminate my denominators. 6 times 2 is 12 divided by 3. 6 times 2 is 12 divided by 3 is 4x. 6 times 5 is 30 divided by 6 is 5, so that's 5x. And then 6 times negative 3 is minus 18. 6 times a half is 3, so that's 3x. 6 times 5 is minus 30. And then I'm going to start combining like terms. So I have 4x and minus 5x on this side, so that's going to give me my negative x minus 18 equals 3x plus minus 30. And now you can see that I have one variable term and one constant on the left, variable and constant on the right. So now I'm going to start moving my terms. I'm going to choose to move the x's to the right. Again, I like to keep my x's positive. If you like to always go variables to the left, constants to the right, feel free to do that. But since I'm moving my variables to the right, I'm going to move my constant to the left. And I'm going to add 30 to both sides. And that gives me 12 equals 4x. And then when I divide by 4, x equals 3. So my solution in set notation is simply 3. So there are 3 types of equations we deal with. So far, we've only dealt with this first one, conditional equation. That means it's true for some value of the variables and false for others. You have a definite solution. There are 2 special cases. One is called the identity, and identity means that for all values of the variable, the equation's going to be true. In other words, no matter what I put in, I'm going to get a true statement out. A contradiction is opposite of that. A contradiction is no matter what I put in, it's not true. So there's no solution. So an identity is when we have infinitely many or all real numbers work. A contradiction is when we actually have no solution. So let's look at an example of that. So let's start from the inside of these brackets. I mean, this one looks really complicated, but in reality, I just have to be patient and simplify. So on the left, and this, because of how much simplifying we got to do, I'm going to draw this little line. We need to distribute. So that's going to give me 2 bracket 4 plus 2 times 5 is 10. 2 times -1 is minus 2x. Minus 2x, close the bracket. Now, I'm not going to distribute first. I think I want to simplify what's in this bracket before I have to do distributing. So I have 4 plus 10, that's 14. Negative 2x minus 2x is minus 4x. Now I can distribute, and I get 28 minus 8x. So my left-hand side ends up being 28 minus 8x. On the right, I need to just distribute. One simple step, so I'm going to bring it on down. 4 times 7 is 28. 4 times -2 is minus 8x. Now, if we follow the steps we've been following, I'm going to choose a side to move my variable to. So let's say I move my variables to the left, and I move my numbers to the right. So variable to the left means I have to do it plus 8x. And numbers to the right means I need to do minus 28. But notice what happens when I do that. 28 minus 28 is 0. Negative 8x plus 8x, that leaves me with 0 on the left and 0 on the right. But 0 does equal 0. This is a true statement. That means this is an identity in which all real numbers will work. So I can plug 2 in and I'm going to get a true statement. I can plug negative 100 in and I'm going to get a true statement. It's going to, every real number is going to work in this problem. Okay. Now, let's look at this next one. Same setup, same starting out. Okay. I simplify the inside. So that gives me 2, 4 plus 10 minus 2x minus 2x. If you notice, it's actually almost exactly the same problem. Go ahead and distribute that. So when I combine like terms, I get 14 minus 4x, just like I did in the previous problem. And then when I distribute, I get 28 minus 8x equals 28 plus 8x. So when I do my movement, I'm going to move my variable to the right, keep it positive, and I'm going to move my constants the other way. And what do I end up with? Well, 28 minus 28 is 0. 8x minus or plus 8x is 0. So that side is 0. That cancels out. But 8x plus 8x equals 16x. So when I divide by 16, 0 divided by 16 is 0. Now, please understand, this is not a no solution problem. The answer is 0, period. This is what we would call it a conditional equation because the answer is 0. Last example of this, let's work on this one. We need to distribute so that we can simplify the left, simplify the right. Please note that this is distributing -1 here. And so I get negative 3x plus 6, because I'm distributing -3, plus 8x plus 20 equals 10x minus 5x plus 23. So then I'm going to combine like terms. Well, in this case, I have a couple of like terms here. I got negative 3x plus 8x, which is giving me my 5x. And then I've got positive 6 and positive 20, which is going to give me my plus 26. Over here, all I've got in like terms is 10x minus 5x. And so that's going to give me 5x plus 23. Then when I move, let's say I move my variables to the left, which makes my constants going to go to the right. That gives me minus 5x and minus 26. So what the result gives me 0 on the left and -3 on the right. Well, does 0 equal -3? Well, no, 0 does not equal -3. So therefore, this is a contradiction, so there is no solution. This is a contradiction, therefore, it's no solution.